until I found this photo from Grand Mere State Park. This is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline. Very interesting. Here's what's happening. This is a good example of a superior mirage. So Joshua was on the Lake Michigan shore. He was looking towards the west, and Chicago's beyond the horizon. Should not be able to see it. However, with the right conditions, we have an inversion. We have cold air near the cold lake water and some relatively warmer air above it. This will bend the image of that skyline back towards the viewer. And so typically we would not be able to see this. This image would be viewable from much, much higher in the sky, up in space. But instead, we're able to see it.
Now this is what they tell us. This is mainstream refraction. They say that the light is being refracted downward due to the gradient, density gradient. Temperature plays an effect, they say, but not near as much. It's mainly the density. But the light refracts downward, and which makes the objects appear higher. And that's why they say we see too far right there. And that's Rumpus's famous lighthouse diagram. Okay, so by their own method, I want to demonstrate a couple things. Okay, so what you have here is this guy, I think Pebble in the Pond or Peter the Great, or shout out to him, and shout out to Ranty's channel, Brandon, where this video come from. What this demonstrates, okay, we put it to the test. The newsman said the cold air on the lake is causing a mirage, and that's the reason we've seen the Chicago skyline. But you know, the bottom of the buildings in that Josh Nowicki photo, the very bottoms of the building were missing. You know, we shouldn't have seen any of the buildings, but there was a little bit missing. But so this leads to my theory. So we demonstrate what happens. You know, this guy's about, this here is a warehouse floor. And I think he's about a couple 100 feet away. He's got that white light right on the ground, about an inch off the ground. He's got his camera about an inch or two off the ground. And then the green light next to it's just a little bit higher. And then that reddish light over to the left is even still a little higher, probably about 5 inches. Okay, so where he's at in this warehouse, he said it's about 70 degrees inside the warehouse, 72 maybe. And it's just a little bit above freezing, probably around 32, 33 degrees Fahrenheit outside. So he opens the warehouse door. Okay, and this is what happens. So he opens the warehouse door, lets all the cold air in, and what do you know? White light starting to go, and the green light starting to go, and look at the red light over there, making an inferior mirage. Exactly what we see the sun do, mirroring off the water during sunset. So this guy's done plenty of demonstrations like this from different distances on different sides of the warehouse, but when he lets that cold air rush in and it comes up under the warm air, whatever it may be, it's in real life, that's what you see every time. And he's done it several different ways. And I'm going to show some other evidence of how a sun would set, how a sun could set, and it's very plausible. Wait till you see my evidence. I wanted to add, after a couple minutes, the green light comes back in full at first, and then the white light starts peeking up above the blockage. Okay, so what we have here is a guy putting balloons into liquid nitrogen, basically demonstrating what extreme cold does to air. He's putting them in there, and these balloons are just shriveling up down to nothing. Now the air is still in there, okay? He pulls them out, and it just takes a second. They blow back up. So the air is there. So there's no vacuum up there, in my opinion. At higher altitudes, about 40,000 feet, maybe 50,000 feet, the temperature gets down to as low as -80, and then you keep going a little higher, and that's that one layer where the pressure, it keeps getting colder, then you hit that at -80, and there's about 50,000 feet layer from probably about 40 to 90,000 feet where the temperature warms up to as much as like positive 30 degrees Fahrenheit. So that's a 110-degree temperature swing. But naturally, in my opinion, the pressure would have to go up, and so that's a clue in what's coming. So this plays a big part in the sunset, is that layer there. So stay with me, and you see them balloons blowing right back up. That one pop, couple of them pop, but they shrivel down to nothing. I mean, we can't ignore these things. These things we didn't know. We didn't know this when we were making our model and doing our. We're learning new things. We got to update our paradigm, in my opinion. We got to open our minds. But stay with me. Okay, so what you have here is some pages from Google with various temperature and pressures and humidities at higher altitudes. There's a lot of conflicting information, and in my opinion, where you see conflicting information on mainstream science, then you're on to something. And I've been studying this and looking at different phenomenons and unexplained videos for quite a while now, and I'm trying to come up with an explanation on what the sun is, what I think it is, and how it could set being local over a plane. And in my opinion, the sun is a focal point of light. It's a unique kind of polarized light. In my opinion, the sun's probably about 10, 20,000 miles away, but it appears to be about, I don't know, 7 to 15 miles is my guess. And it's that layer where water vapor pretty much comes to a screeching halt and the temperature inverts. It gets super cold until you hit about 40,000 feet, which is right above the commercial passenger planes, and where like extremes of -80 up to about positive 30 Fahrenheit. That's a 110-degree temperature change. To me, that's right where the sun rears its ugly head. But nah, it's a focal point right there in that area, and I'll give you a few reasons why. But first, I want to tell you about these clouds behind the sun. At first, I bought the explanation that the sun is washing out the clouds, the light's washing out the clouds. But then you see a plane going through it, and you see birds going through it. You see it in a valley, and you can't just keep ignoring and acting like they're not capturing this phenomenon. It's whatever the case, it's apparent right there, and it's unique to the observer. So if I'm looking at the sun on the horizon or even above the horizon, it's lighting up clouds right around it. Okay, and a man 20 miles away from me, he's gonna have this basically the same angle, but he's gonna see different clouds lit up. Okay, now if the sun's 93 million miles away, shining on a sphere, it's gonna have a big hot spot in the middle of the globe, and all the clouds will be lit up. Like I said, it's a unique kind of polarized light. And when you see high altitude balloon footage, which I have towards the end of this video, it's it shows a hot spot on the clouds right in the area I'm speaking of. It seems to be about 20 miles, maybe 25 miles is what it appears to be, but the sun's apparent. That's where it appears to be. And when you get above the clouds in the altitude balloon footage, the sun looks all elongated and glared out. It's not the same. And I think the polarized light could also explain eclipses, but that's for another video. Now, as far as the sun setting over the plane, okay, despite the height, okay, as it goes away from us, it will get lower, but that would not explain it disappearing. Now, at altitude, you see some videos, especially in drier climates, of the sun fading out, but every day the sun dims out to not quite nothing, but almost nothing. It dims out where you could look at it and you're still seeing it peeking over, and there's barely any light where you're at. You see the light off in the distance. The higher you go, though, you see it fade out occasionally. It's not very common, but you do see it. So the sun has a limited reach. But that layer of 7 to 15 miles where the temperature changes, so they explain the Chicago skyline as the cold air over Lake Michigan being denser because it has less water vapor. I'm okay with that. And I do not argue with the science. They figured that out a long time ago, that light refracts toward the denser median. Okay, but if you watch that warehouse floor and the lights on the warehouse floor earlier in this video, that guy's done this several times from different distances, and when he opens that garage door and lets the cold air in, the light at the bottom, white light, disappears, and then the green light, and then the red light over on the other side that's a little bit higher, it looks just like the sun on the horizon, like an inferior mirage, a reflection of itself. It's kind of dipping into itself, kind of. But the light, with that, but here's my explanation. So the cold air is making the light bend down, and the explanation is it makes the buildings look higher. And I'm not completely buying that, because if you look at the Chicago city skyline, if you see it, it's missing a little bit of the bottom of the buildings, even though none of the buildings should be visible, whether they want to admit it or not. None of the buildings should be visible, but almost all of them, all the building is visible, except the very bottom, and that's because of the refraction, just like we've seen at the warehouse floor. Okay, but but as far as the sun refracting and setting, okay, like I was saying, at about 40,000 feet, the air at -80 is like the air in the balloons. It's just shriveled down to almost nothing. But then it climbs up to about +30. So normally the warmer air would be less dense, but there's no humidity up there, none to speak of. And they say pressure plays more of a role in refraction, but there's no pressure to speak of up there either. And so over a long distance, with the air getting more dense, the higher you go there for about 10 miles, over vast distance, let's say 6,000 to 8,000 miles, then you're gonna the light's gonna start bending upwards, making the sun appear lower till we can't see it no more. That would also explain the AE map. The sun, it ain't quite even. It's close to covering half the Earth, but it ain't quite even, because it should shine over the North Pole a little bit. But mainstream science is bragging now how they have slowed light down to 10 meters a second, and it's not near as fast. And even though the temperatures aren't that extreme in the Arctic, they are very, very cold, and it is a way longer distance. So it could stop the throw of light and equalize. But in my next video, or the one after that, I'm gonna explain the stars and the eclipses. I may have one more on the sun, but you know, if you leave a you know, if nothing else, this is a good starting point and a conversation piece. Okay, it can't be wrong because it's my opinion. Okay, but I did add a lot of facts and a lot of evidence, and you know, we could be like the old men from the Royal Institute of Science back in England, and nope, this science, we're standing on the shoulders of giants, you know, and this is how it is, and this is how it's gonna be. Or we can get with the times. So make your choice, but subscribe for the next videos. Thank you.